Okay, this is part 2 of the Super Smash Bros. Cam remake. If you're not sure what we're doing, just visit part 1 of this video and watch the beginning. You'll get an idea. So we already have our move randomly script set up. So next thing we're going to work on is the level focus script. So I'm going to make a new script. I'm just going to call it focus level. Naming doesn't really matter. Alright, so let me go ahead and open that up. Looks like it loaded on my other screen, so let me drag it over here. There we go. Okay, so we don't need the start. We do, however, need the update. So I'm going to make a couple public variables so we can access them from anywhere. And I'll tell you what they are as soon as we get done typing it up. So we've got half x bounds, half y bounds, and you guessed it, half z bounds. We don't really use the half z bounds, but just in case you want to implement something later, it's there. And then we need the public bounds, focus bounds. And if you're not sure what a bounds is, you can look into it. Basically creates a box around a given set of areas or positions. So the half x bounds is how far out on each side you want your camera to focus from the center of the level, or rather the level focus. To give you an idea what I'm talking about, let's go ahead and jump back to Unity and select the level focus. You can see it's right here in the center of my level. So if I have 20 units out, we'll just pretend I'm going to move this cube. We'll pretend that's 20 units out. So once you pass those 20 units, the camera is going to stop caring about this cube as much, and it's going to start focusing on the other two cubes that are still in the level. That's important because you don't want the camera wandering off too much to the side and deviating away from the level to focus on the player. That's clearly not where it should be. So that's the idea of what we're going to be doing here. So I'm going to go with 20, 15, and 15 to start. Now on the update, I'm just going to do vector 3 position. Now I'm going to set that to my game object's position. I'm going to make a new bounds. And I'm going to encapsulate basically our dimensions using our half bounds. Now encapsulate is essentially adding the positions to the bounds. I'm going to do new vector 3 position.x minus half x bounds, position.y minus half y bounds, position.z minus half z bounds. And then I'm going to do the exact opposite except with positive numbers. So I just copied and pasted this, and all I'm going to do is just change the minus signs to the plus signs. Oops, man, I'm not doing very well at typing today. Alright, so I'm just going to go ahead and set that up, and that's all we have. Oops, I almost forgot something. Set the focus bounds as your new bounds. So that way it's updating the public variable. Okay. So we're just going to go back into Unity Engine, select the level focus in the hierarchy, add component, focus level, and there you go. That's all you have to do for that. Now we get to work on the fun part, which is the camera script. So go ahead and make a new script. I'm just going to call it soupcam or supcam. Going to open it up. Okay, so there's going to be a lot of work in this, so I'm going to take some pauses between steps, so if you need to kind of refresh or go over it, give you the time to do it. So the first thing we need to do is public focus level, focus level. This is going to be the script that we just made, and that way we can access it easily and other information about it. So we're going to need public list game object players. This is going to be tracking all the players on the board. You would want to add to this list as you load in players or unload players. So that's what that's for. And then the following ones will control how quickly the camera updates. So we're going to look at depth, update speed. We're going to go with 5. And I've already kind of messed around with these values, so this is just what I like, but you can of course change them as you see fit. Angle update speed equals 7, not 5. Oh my gosh. There we go. Public float position update speed equals 5f. Okay, so what we're looking at, the depth update speed is going to be how quickly the camera zooms in and out. The angle is going to be how quickly it pans up and down, and the panning can give you a feel of having more depth. You'll see it as we run through it, and we'll change the values later. The position update speed is how quickly it moves left to right, top to bottom. Alright, so now we're going to need a couple more things. We're going to need, what was that? I don't even know what that was. Okay, we're going to need a public float depth max equals -10. Public float depth min equals -22. You might be wondering why the max is higher than min. Well, because it's actually a higher number when it's closer to 0, so that's why I did it that way. This is going to be how far out the camera can zoom at most and how far in it can zoom at most. So now we just need to do one for the angle as well. You don't have to do the F after everything, it's just habit for me. Not necessary at all. Do private float camera Euler X. This is going to be for the angle. You can rename it something else if you want later, but I'd recommend keeping it that just so you don't get confused later in the video. Private vector 3 camera position. This is going to be where the camera is going to be both in depth on the X and Y plane as well. So I'm going to go ahead and pause a moment here. Make sure everything's right. Okay, so let's go ahead and save it. Then go to the engine. Select your camera. Go ahead and add the subcam script. And you can see we have the focus level variable, so I'm going to go ahead and drag the level focus over to it. And then we have your players. So I'm going to highlight all the players on the left. Actually, as you can see, it just deselected it. So I'm going to go back to my camera, click the little lock in the top right, and you see it's closed now. That will make sure this window stays in focus while I select other objects. So now I'm going to select the players. I'm going to drag them over to the players. Okay, so now we can go ahead and go back to the code. Under start, I'm going to add the level focus game object, or the focus level game object, to the players list. That's because I want it to be considered in the calculations as a player. Make 2 placeholder methods here. We're going to call one move camera. We're going to call another one calculate camera locations. Okay, and then an update. We're actually going to change this to late update because we want it to update after everything is drawn to the screen. So we're going to first do the calculate method, then we're going to move the camera afterwards. So we're going to go ahead and jump to the calculate camera locations because that's where most of the magic's going to happen. And it's not much code, but it is a little complex, so I'm going to describe it best I can. So the first thing we need is the average center of all the players. So I'm going to make a new variable called average center. Just give it a 0 value to initialize it. I'm going to do the same thing for total positions, this will be the sum of all the positions of our players. And we need bounds, player bounds. This way we can get the extent of our players. So basically the box I was telling you about, using all their positions. And now we just need to cycle through every player. So I'm going to do a for loop using the players.count as the length. And the first variable we're going to have in here is vector3 player position equals players I, so whichever player we're accessing in the loop here, transform.position. And the first thing we need to do is check if the player is within our focus bounds. So you may remember that we set up the focus bounds previously in here, right here. So how we're going to do that is quite simple. If focus level dot focus bounds dot contains player position. So actually, I'm going to change this to doesn't contain player position. So if player is outside of this position, we're just going to update the vector3 that we pulled to stay within those bounds, but retaining the other information as well. So let's say if they're out of the left bounds but they're within the Y bounds, we're just going to update the left bounds to match what's on the focus level. So we need to do float player X, float player Y, float player Z. Alright, so now back up to the X. We're going to do equals mathf.clamp player position.x focus level.focus bounds.min.x, and then focus level focus bounds.max.x. So this clamps the player X to the absolute left and the absolute most of our focus bounds. And we're going to do the same thing for Y and Z, but so instead of writing it all out, just going to copy it, delete the semicolon and paste it, and change the X's to a Y, because who doesn't like saving time? Same thing here, except change the X to a Z. That's all you have to do to clamp those in. Now we need to add our clamp position to our total positions. So I'm just going to do total positions plus equals, which adds on to the existing variable, player position. And then I'm going to add it to the player bounds as well. So encapsulate, like before, player position. Okay, now we just need to get the average center. That's going to be really easy to do, so we're just going to take the total positions that we just calculated and divide it by players.count. Okay, now we're going to do float extents, which is going to be a total of the X and Y extents of the player bounds. Because we don't really care about the depth. That's not going to really affect the camera for our needs anyway, so we're just going to ignore it. Then we're going to do float lerp percent, so this is going to be a value between 0 and 1, equals mathf inverse lerp 0. So we're going to be determining how far the extents are and what percentage between 0 and a given value. So we're going to use 0 and focus level dot half X bounds plus focus level dot half Y bounds, and we're going to divide that by 2, and we're going to plug in our extents because that's the value we're checking. So if you're wondering why I use divide by 2, basically if this is, let's say, divide by 1, so it's going to be exactly half X bounds plus half Y bounds. This means it's going to let the players go out a lot further before it considers expanding the camera more. So if we're going to shrink it a little bit, it'll make our lerp percent be closer to 1 quicker with our players not having to go out as far. So if you feel that that's not working out, you can change it to 1.5, 1.25, whatever you want if you want to give the players a little more freedom. Or you could even change what I recommend is change the actual half X and half Y bounds instead, because that's how the code is intended to work. So now we're going to calculate the depth, which determines how far the camera will move in and out. We're going to use depth max, then depth min, and then lerp percent. So the closer the lerp percent is to 1, the more likely we are going to be towards this value, the depth min. And as we looked at earlier, let me go back to my camera, the depth min is actually the higher value, which means further away. So what that translates to is the further the players are from each other, the further away the camera is going to get. We're going to do angle, mathf.lerp, angle max, angle min, lerp percent. So now we just need to update our values. So I'm going to do the camera Euler X, which is what we made earlier, equals angle, camera position equals new, vector 3, average center dot x, average center dot y, and then the depth we just calculated. So that should be all we need to do. Let me just double check my work. Yep, so that's all we have to do in calculating the camera location. It's not that much code. It's pretty efficient as well. You don't have to worry about much overhead. So now we have to actually move the camera. So under the move camera method, first thing we need to do is make a vector 3 position, which is going to get our game object's current position. If position is not where we want the camera to be, which is camera position, which is our target position, we're going to do vector 3 new position equals vector 3.0 just to initialize it, and then we're going to do new position dot x equals mathf dot move towards our current position, which is position dot x, our target position, which is camera position dot x, and our move speed, which is position update speed times time dot delta. Remember to use time dot delta time. Your frame rate will change and update will fire on every frame, so you don't want this to be sporadic. You want to use time dot delta time. So to make things quick, I'm just going to copy and paste 2 more times. I'm going to change the second one from x to y. And mathf move towards is basically the same thing as vector 3, except it's using it on a single plane, so just x, y, or z, or whatever it may be, instead of calculating all 3 planes at once. So with the z, we're going to change the positions, except where it says position update speed, we're going to change this to depth update speed. This will allow you to change how quickly it moves left to right, top to bottom, separate from how quickly it zooms in and out. So now we need to check the angles to make sure that the tilt on the camera is set up right. So vector 3 local Euler angles equals game object dot transform dot local Euler angles. If local Euler angles dot x does not equal camera Euler x, because this is the only one we care about, is the x value, because that's the only one we need to adjust for tilt, so that's the one we're going to check against. So if it does not equal that, we're going to do vector 3 target Euler angles equals new vector 3, and we're going to pull the x from our target x, and we're going to use the already existing Euler angles, local Euler angles for y and local Euler angles for z, because we only want to adjust the tilt. We don't care about anything else. And then we're going to go ahead and do that. So we're going to go game object transform local Euler angles equals vector 3, because we want it to move smoothly, We don't want it to be all at once. Move towards, and we're going to do local Euler angles, which is the current angles as a starting point. As you can see, it says current. And target Euler angles as the destination. And then we're going to use the angle update speed times time.delta. Okay, and you would think I would probably use target position here, which I'm going to actually do so, just because I'm finicky about that. So I'm going to update that, rename new position to target position. I actually forgot something here, so I need to update the transform.position equals target position. There we go. Alright, so this is what it should look like in the end. So I'm going to go ahead and save, let you take a quick look at that. And I'm going to move over to the project. Okay, so I'm back in the subcam script. When I was doing a little bit of testing, I noticed something wasn't working, and I realized I made a mistake. So I'm back in the calculate camera locations. And I need to go back to this part right here, where it checks if a player is out of bound. And I adjusted the values and their own little individual floats, but I did not actually update the player position variable. So that was fail on my part. So I'm going to do player position equals new vector 3, player x, player y, player z. And I'm going to fix that y there. Okay, so now I'm going to jump back into the editor. And don't mind what I'm doing right now. I just disabled the move scripts, so I'm going to recheck them. And if you don't have this window, make sure you have the lock removed in the top right. Because if you stay locked on the camera, which you probably still are, when you click other objects, it's not going to show them. So make sure you remove that lock if you can't see what I'm seeing right now. So I'm going to go ahead and hit play. And you can see that it's favoring the players closer to the level, while at the same time favoring the players that are closer to each other. So it wants to stick to the group of players, but also consider the center of the level as well. So let me show you what happens whenever one goes too far off the screen. So I'm going to go ahead and disable the move randomly script. I'm going to hit play again. And we have this guy right here, which you can see as he moves in closer and further away, it does work, but if I move him past a certain point, it stops tracking him. You can see I'm moving on the left, but it stops tracking him because you don't want to go too far off. And it's going to do the same thing with the up and down. See how it stops tracking at a certain point? Okay, now here's the idea of the level focus. Let's say the center of your level is currently right here, but for some reason, let's just pretend here, I'm going to add a giant cube, which we're gonna say it's like, okay, it's not very giant, is it? It's a little bit bigger. There we go. We're going to add this giant cube, which we're going to pretend is some sort of monster appearing in the level. And you want to focus on this new level aspect instead of the old part. So instead of having to do a lot of recalculations, you can just move the level focus over this way. And now you'll see when I turn on the player scripts that it will favor this part of the level instead of the center. And you can tell it's hanging out a little more to the right. If you're not terribly sure, I'll move it over more and I'll show you. As you can see, it goes with the level focus. And it also adjusts the bounds of the players as well. So if I turn off the move randomly, let's go ahead and move this guy down. And if I move him out, it's not tracking him anymore. But if I move the level focus over and then start moving him, it tracks him again. So the tracking is related to the level focus. So that could be very handy if you want your level to have dynamics and change. That really concludes the end of this. If you have any questions, post in the video comments. I'll certainly try to help.